Assalamu alaikum dear students. I am your computer teacher, Miss Neha Rizwan. I hope you all are fine. Now let's start chapter number 2, binary computing. What is binary computing? Binary is a base 2 number system invented by Gottfried Leibniz that's made up of only two numbers or digits, 0 and 1. This numbering system is the basis for all binary code which is used to write digital data such as the computer processor instructions used every day. So the first topic is the computer, a digital machine. We now live in our digital world. You all must have heard this phrase, but have you ever wondered what it really means? Computers are electronic machines. They understand data in a digital form. Digital data is discrete. Humans understand data in an analog form. Computer needs to translate analog data into a digital form to understand it. And what is data? Data is a collection of raw facts and figures. It is often meaningless. There are three forms of data. Number one is numeric data. Data in the form of numbers is called numeric data, and numeric data consists of digits and the decimal point. Second form, alphabetic data. Alphabetic data consists of a fixed sets of alphabetic characters. And the third is alphanumeric data. Alphanumeric data consists of letters of the alphabet, numbers, and other special characters. The second topic is binary states. What happens to a light bulb when you switch it on? And what happens to it when you switch it off? The bulb glows in the first case and turns off in the second case. There is no case in which the bulb is slightly on or slightly off. This happens because of the flow of current along the wires in the circuit. The bulb will turn on if electric current is flowing in the circuit. It will turn off when electric current is not flowing. Only two situations are possible. Either current flows or it doesn't. Let's represent these two situations by the digit 1 and 0 respectively. Something similar happens inside the CPU, like the light bulb. The computer also runs on electricity. Circuits in the processor are like the wires connected to the bulb. They carry signals in the form of electric current. You can see these circuits by observing the memory unit of a processor under a powerful microscope because these circuits carry electricity. They can be in one of the two states, state 1 or state 0, depending on whether electric current is passing through them or not. Whenever we press a key on the keyboard, electronic signals are sent to the processor. The processor understands these signals and stores them. So the next topic is number system. Let's discuss how the two different systems use numbers to represent the same thing in different ways. We know that the English alphabet has 26 letters. We use the 26 letters in different combination to make different words. Similarly, we know that there are 38 letters in the Urdu alphabet. We use these letters in different combination to create different words. We also know that there are several words in the English and Urdu languages that means the same thing but use different letters to write them. In the same way, we can only use numbers to mean different things. For example, we normally use the digits 0 to 9 to represent small numbers like 2 and 5 and large numbers like 5900 and so on. Because this number system uses 10 digits, 0 to 9, it is called the decimal system. There is another system that we use only two digits, 0 and 1. In different combination to create different number. This system is called the binary system. Are there only two number system? No, there are several number system. Let's discuss four commonly used number system. Number 1, the decimal number system. Number 2, the binary number system. Number 3, the octal number system. Number 4, the hexadecimal number system. The decimal number system or base 10 system is based on 10 digits 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. These digits are combined in different ways to represent different values. The binary number system or base 2 system is based on two digits 0 and 1. These digits are combined in different ways to represent different values. Number 3, octal number system. The octal number system or base 8 system is based on 8 digits 0 to 7. These digits are combined in different ways to represent different values. Number 4. The hexadecimal number system. The hexadecimal number system or base 16 system is based on 16 values. 16 values means 0 to 9 and the letters A, B, A to F. Clear? These digits are combined in different ways to represent different values. Next topic is character. Characters are the alphabet's keys, number keys and special keys on the keyboard. In other words, they are what you see on the keyboard when you press the key on the keyboard. Each character is converted into a unique pattern of 1s and 0s. For example, the letter capital A is represented as 65 under the decimal system and as 0, 1, 00, 0001 under the binary system. Similarly, the letter A, small a, is represented as 97 under the decimal system and as 0, 11, 0001 under the binary system. So the question is, how is this code created? Now see, binary coding scheme. What is binary coding scheme? Binary coding schemes are used to convert the characters into binary form and vice versa. There are three coding schemes in common use. Number 1, the ASCII code. ASCII stands for American Standard Code for Information Interchange. Second is the ABCDIC code, and ABCDIC code stands for Extended Binary Code Decimal Interchange Code, and the ABCDIC code is used in mainframe computer. Third is Unicode. Unicode is a coding scheme that was developed in the 1990s. It developed codes for a large number of characters including Chinese and Japanese ones. It has become the most commonly used code to store data on microcomputer after surpassing ASCII. आपका next topic है conversion of decimal number into binary number. How to convert decimal number into binary number or how to convert decimal system into binary number system. First of all, आपका नंबर है कन्वर्ट करना है, आपको 39 को कन्वर्ट करना है बाइनरी सिस्टम में. तो आप उसको कैसे कन्वर्ट करेंगे? 39 अपना नंबर यहाँ पे लिखा और फिर आप उसको कौन सा मेथड यूज़ करेंगे? आप डिवीजन मेथड यूज़ करेंगे. डिवीजन मेथड यूज़ करने के लिए सबसे पहले हम छोटा नंबर लेंगे. 2 हमने लिया और 2 1 सा 2 करके 1 इसके पास कैरी बचा. 2 9 सा 18. यहाँ पे मेरे पास 1 रिमाइंडर बचा तो 1 मैंने यहाँ लिख दिया. अब उसके बाद आ जाए 2 के रिमाइंडर में 90 नहीं आता तो 2 9 सा 18, 1 रिमाइंडर बचा. उसके बाद अगेन 2 4 सा 8, 1 हमारे पास अगेन रिमाइंडर आया और 2 2 सा 4. यहाँ पे हमारे पास कोई रिमाइंडर नहीं बचा. 2 1 सा 2, 0 रिमाइंडर. Stop the division process when the answer comes to 0. Collect the remainder in reverse order. अब देखिए आप अपना आंसर किस तरीके से लिखेंगे. सबसे पहले आप यहाँ से स्टार्ट करेंगे इसको. ये एरो से मैंने शो कर दिया है, ठीक है. सबसे पहले हम ये वाला नंबर लेते हैं. यहाँ पे 1 था आपका, 1 लिखा आपने पहले. 1 0 0 0 1 1. और ये हमारा बाइनरी सिस्टम था, इसलिए हमने यहाँ पे 2 लगा दिया. ये आपका आंसर कंप्लीट हो गया. What is bit? A bit is derived from binary digit. It is the smallest unit of data a computer can process or understand. Each binary signal means 0 or 1 or electronic pulse is recorded in the memory location as bit. This means that all data in a computer is stored in the form of electronic pulses. The size of a computer's memory is measured by the amount of electronic signals that can be stored in it, but the memory is not measured in bits. Larger units called bytes are used. A byte is usually a combination of 8 bits. Each byte represents a character on the keyboard. A combination of 8 bytes make up 1 byte. When we talk about memory sizes, we refer to memory size in terms of kilobytes, megabytes, or gigabytes. Let's discuss these larger units. 1 KB or 1 kilobyte equals to 1024 bytes. 1 MB or megabyte, 1024 KB, approximately 1 million bytes. 1 GB or gigabyte, 1024 MB, approximately 1 billion bytes. 1 TB or terabyte, 1024 GB, approximately 1 trillion bytes. As computers need to process more and more data, processors with great storage capacities are developed. This means that a lot of equipment becomes outdated and useless. Thank you.